Have you ever looked at a mountain and thought, what if this thing was 10 times bigger? Sounds kind of insane, right? Well, that's exactly the wild question one of our viewers asked, and in this video, we're diving right into it. Mount Everest, standing at 8,848 meters, is the king of all mountains. Now multiply that by 10 and you get 88 kilometers. At that point, Everest isn't just tall, it's basically poking through several layers of the atmosphere. To get the idea, let's take a quick look at those layers. Our atmosphere is kind of like an onion, stacked in layers. Troposphere, from the ground up to about 20 kilometers. Stratosphere, 20 to 50 kilometers. Mesosphere, 50 to 80 kilometers. Thermosphere, 80 to 700 kilometers. And exosphere, from 700 kilometers and beyond. A mountain 10 times taller than Everest would even push past the thermosphere, a place where the air is so thin it's basically not there, and the temperature swings are insane. Breathable air? Forget it. Up there, it's pretty much a near-perfect vacuum. So how do mountains even form? We know they're born from the slow and sometimes brutal collisions of tectonic plates. These giant chunks of Earth's crust crash, fold, and push upward to create those majestic peaks. But here's the catch. This process has limits. Even Everest, with all its intimidating height, has reached its maximum stable size. Gravity, pressure, and erosion all team up to keep mountains under control. Pushing mountains to 10 times their size brings up some serious questions. Can Earth's crust even handle that much weight? Probably not. But hey, let's ignore the rules of geology for a moment, okay? Earth's crust, with an average thickness of about 35 kilometers, is basically like the cream layer on a planetary cake. Thin, fragile, and only able to hold so much weight. A mountain 10 times taller would put unimaginable pressure on it. Right now, a mountain like Everest applies roughly 33 megapascals of pressure. Multiply that by 10, and congratulations, you've just created the perfect recipe for a collapsing crust. Earth would literally buckle under the load. Scientists actually believe that if mountains grow taller than about 9 kilometers, Earth's crust can't hold them anymore. The rocks would soften like butter and sink back down into the planet. So, would the weather go crazy? Mountains play a huge role in shaping climate patterns. When wind hits a mountain, it's forced to rise. That cools the air and forms clouds. That's why one side of a mountain is usually green and rainy, while the other side looks like a dry desert, the famous rain shadow effect. Now imagine a mountain 10 times taller. Now, imagine mountains that are 10 times taller. Those climate effects wouldn't just increase, they'd go wildly extreme. On one side of the mountain, you'd get massive, flood-level rainfall creating tiny, isolated ecosystems, and on the other side, huge stretches of dry, barren desert. Global wind patterns, including the jet stream, that high-altitude river of air that shapes weather across the entire planet, would be completely disrupted. Imagine the jet stream slamming into an 88-kilometer wall. Total climate chaos. Now, about a mountain's gravity. Anything with mass creates gravity. Today's mountains do too, but since their mass is tiny compared to Earth, their gravitational effect is limited. Still, if you get close enough to a mountain, you can actually measure its gravitational pull. Now, imagine mountains that are 10 times taller. A mountain's mass increases with the cube of its height, so making it 10 times taller would make it roughly 1,000 times more massive. And remember, gravity is directly proportional to mass. That means that the gravity around these colossal giants would increase noticeably, so much that you might actually feel it. Objects near the base of the mountain could experience a slight pull toward it. Of course, Earth's gravity would still dominate at larger distances. But if mountains became 10 times bigger, what would happen? It wouldn't just be Everest reaching for the sky. Entire mountain ranges would turn into massive atmospheric obstacles. Global wind patterns would twist into a chaotic maze, creating strange deserts and tiny, isolated weather systems. They might even subtly alter local gravity. A fascinating and, honestly, a bit tragic world. Thanks for joining me on this little thought experiment. And if you're not part of Factoria yet, you might want to hit that subscribe button. Stay curious until the next video.